Picture this. A developer asks an AI assistant to build a login system, gets working code in seconds, ships it to production, and unknowingly creates a SQL injection vulnerability that exposes thousands of user accounts. As AI-generated code becomes ubiquitous, a critical question emerges about whether the way we prompt these systems affects the security of what they produce. Let's first examine the scope of this emerging security challenge. The authors identified a critical gap in our understanding. While we know AI assistants can produce vulnerable code, no one had systematically studied whether different prompting techniques could improve security outcomes. This research tackles a fundamental question about whether prompting is just a convenience feature or a critical security skill. They grounded their security assessment in established MITRCW standards to ensure rigorous evaluation. Now let's explore how they systematically tested this hypothesis. The researchers designed a comprehensive case study using a personal notes web application. They systematically tested major AI assistants across common vulnerability categories, generating over 100 prompts to understand security patterns. Their methodology followed a methodical escalation pattern. Starting with basic functional requests, they progressively added security guidance to see what level of human intervention was needed to achieve secure code generation. They focused on critical web application vulnerabilities that every developer should understand. Each category represented common real-world security challenges where AI assistants could either help or harm security posture. The results revealed striking patterns about AI security capabilities. The initial results were sobering. When developers made basic functional requests without security considerations, most AI assistants generated vulnerable code the majority of the time, with some systems failing security standards in nearly 2/3 of cases. However, the story took a dramatic turn with guided prompting. When users provided appropriate security context and specific vulnerability knowledge, nearly every AI assistant could generate secure code, revealing that the bottleneck isn't AI capability but human security expertise. SQL injection results illustrate the pattern perfectly. While some assistants initially generated string concatenation vulnerabilities, targeted prompting about parameterized queries consistently produced secure database interactions across all systems. Path traversal proved particularly challenging, with most assistants initially creating file system access patterns that could allow attackers to escape intended directories. Mitigation required users to specifically understand and request path sanitization techniques. Cross-site request forgery protection emerged as the most difficult challenge. Assistants not only missed these protections initially, but often recommended outdated security libraries, demonstrating how AI training data can perpetuate deprecated security practices. Cryptographic implementations showed mixed results. While assistants avoided obviously broken approaches like MD5 for passwords, they often created subtle vulnerabilities in key management and encryption schemes that required cryptographic expertise to identify and correct. Interestingly, the researchers found a clear distinction between authentication and authorization handling. While assistants could implement login systems effectively, they consistently failed to include proper access control checks, suggesting training data emphasis on authentication over authorization. These findings carry profound implications for security education and development practices. The research reveals that AI assistants amplify existing security knowledge rather than replace it. Developers who understand vulnerabilities can prompt for secure code, while those lacking security awareness will generate vulnerable systems regardless of AI sophistication. This creates a fascinating paradox where AI systems possess security knowledge but require human expertise to access it effectively. The bottleneck shifts from implementation speed to security question formulation, making security education more critical than ever. Like any rigorous research, this study acknowledges important limitations and future directions. The authors transparently acknowledge their scope limitations. While comprehensive within its bounds, the study represents a focused investigation that establishes methodology for broader future research across more applications and languages. Future research directions point towards scaling these insights through automation and broader empirical validation. The integration of static analysis tools could create feedback loops that automatically improve prompting effectiveness over time. This research fundamentally reframes AI-assisted development from a productivity tool to a security collaboration that demands expertise on both sides. The title says it perfectly: despite AI assistance, you still have to study security to build secure systems. Visit emergentmind.com to explore more cutting-edge research at the intersection of AI and cybersecurity.